Now how to prove the first one? Proof of first one. So sin h of x plus y is equal to sin hx into cos hy plus cos hx into sin hy. Okay. We can do it in two ways. Either we can take from left to right, or we can take from right to left. Okay. Suppose we are taking left to right. Now sin h of x plus y is equal to, by the definition of the hyperbolic function sin h of x, we have sin h of x is equal to e power x minus e power minus x divided by 2. So sin h of x plus y will be what? E power x plus y minus e power minus of x plus y divided by 2. I hope you are okay with it, because sin h of x is equal to e power x minus e power minus x divided by 2. We are replacing x here by x plus y. So sin h of x plus y is equal to e power x plus y minus e power minus x plus y divided by 2. Okay. So this is nothing but this is equal to e power x e power y minus e power minus x into e power minus y divided by 2. Okay. Now we can replace e power x and e power y and e power minus x and e power minus y by the equations we obtained from the previous example. So this is 1 by 2 into, we have e power x is equal to what? Cos hx plus sin hx. Okay. Cos hx plus sin hx. This is e power x into e power y will be cos hy plus sin hy minus e power minus x was what? Cos hx minus sin hx. Cos hx minus sin hx into e power minus y will be cos hy minus sin hy. Okay. Now just multiplying this 1 by 2 into what? Cos hx into cos hy, cos hx into cos hy plus cos hx into sin hy plus sin hx into cos hy, sin hx into cos hy, then sin hx into cos sin hy plus sin hx into sin hy. Now negative of cos hx into cos hy, cos hx into cos hy, then cos hx into minus sin hy, that is cos h minus cos hx into sin hy, then minus sin hx into cos hy. So negatives here, and negative what? Sin hx into cos hy and sin hx into sin hy plus sin hx into sin hy. Okay. Now this is 1 by 2 into. So we are deleting if we are deleting the equal terms, or cancelling the equal terms, what? So we need to get sin hx into cos hy, cos hx into sin hy. So cos hx into cos hy, cos hx into cos hy get cancelled. This is plus and this is negative. Okay, so this term will be get cancelled. Then cos hx into sin hy, then cos hx into sin hy. This also get cancelled. This term and this term. Oh, sorry. This is plus cos hx into sin hy, negative plus cos hx into sin hy. So 2 into. So this is 2 into cos hx into sin hy. So this and this. So these are. Then sin hx into cos hy minus sin hx into cos hy. So minus and minus plus. So plus 2 sin hx into cos hy. So this is over. Then this term and this term is remaining. Sin hx into sin hy minus sin hx into sin hy. This will be cancelled. Okay. So this is nothing but 1 by 2 into 2 cos hx sin hy plus what? 2 sin hx into cos hy. So dividing 2 we'll get sin hx cos hy sin hx into cos hy plus cos hx into sin hy. This is RHS. Okay. So LHS is equal to RHS. So we proved the first identity, sin h of x plus y is equal to sin hx into cos hy plus cos h into sin hy. In a similar way, you can say we can solve prove this cos h of x plus y equal to cos hx into cos hy plus sin hx into sin hy. Okay, I am leaving this to you, so you do this. Next one. Next we can talk about the derivative of the hyperbolic functions. Okay, derivative of the hyperbolic functions. Before that we can formulate one more identity, because the half angle identity. So this is, for example, one more identity. Okay, first one is sin h square x is equal to cos h 2x minus 1 divided by 2 and cos h square x is equal to cos h 2x minus 1 divided by 2. Sorry, plus 1 divided by 2. Cos h square is equal to cos h 2x plus 1 divided by 2 and sin h square x equal to cos hx minus 1 divided by 2. Now how to do this? Okay, these are half angle identities of the hyperbolic functions. Now we have to prove this. We have cos h of x plus y is equal to cos h of x into cos h of y plus sin h of x into sin h of y. This is important because cos of x plus y was what? Cos x into cos y minus sin x into sin y. But in hyperbolic functions, cos h of x plus y is nothing but here is plus cos h x into cos h y plus sin h x into sin h y. If we replace y by x here, if x equal to y, then from this equation we get what? Equation number 1 2x. So x plus y equal to 2x. Cos h of 2x is equal to cos hx into cos hx. So 2 cos hx, right? Sorry, cos hx into cos hx. So cos h square x plus sin hx into sin hx. So sin h square x. So we need to find cos h square x and sin h square x. So first of all we can find sin h square x. From this we get sin h square x is equal to cos h 2x minus cos h square x. So to get this, here is cos h 2x and we have to eliminate this cos h square x. So for that we have the identity what? Cos h square x minus sin h square is equal to 1, right? Sin h square x equal to 1. So from this we get cos h square is equal to or minus cos h square, or cos h square is equal to 1 plus sin h square x. Okay, so replacing cos h square here we get cos h 2x minus cos h square is equal to 1 plus sin h square x. Okay, not getting this right. Okay, so this is 1 plus sin h square x. So this is nothing but cos h 2x minus 1 minus sin h square. So we can take to here. So this is 2 into sin h square x is equal to cos h 2x minus 1. So So here was minus sin h square. So adding minus sin h square, we get 2 sin h square x equal to cos h 2x minus 1. So from this we get sin h square x is equal to cos h 2x minus 1 divided by 2. This is the identity. Okay. In a similar way we can find sin square. Okay. From this also number as 2. Now to find cos h square x, from 2 we get also 2 implies what? Cos h square x is equal to what? Cos h of 2x minus sin square x, right? So from this we get sin h square is equal to cos h square minus 1. So replace this. This is equal to cos h 2x minus, we get minus sin h square is equal to 1 minus cos h square. We can replace that plus 1 minus cos h square x, since cos h square x minus sin h square x equal to 1, right? So from this, in a similar way, we'll get cos h square x plus cos h square x. 2 cos h square x is equal to cos h 2x plus 1. So we get cos h square x is equal to cos h 2x plus 1 divided by 2. Okay. So this is the second formula or second identity.